Now, in this problem here, we're given this function. It's a cubic, and we want to find the maximum and minimums on this interval. So we're only interested in going from 0 to 5. So we can look for relative max and mins, but also what is the absolute, the biggest and the smallest y values of this function. So we know what to do. We need to start with the derivative, so let's do that. So we'll get f prime of x equals 3x squared minus 4x minus 4. So let's ask our two questions. So first of all, where, if anywhere, is f prime of x equal to 0? And remember, what that is going to show us is where the smooth max, smooth min, and these saddle points, not saddle points, but terrace points are. So let's see, we'll get f prime of x equal to 0. Here's f prime, 3x squared minus 4x minus 4 equals 0. Let's see if we can factor this. So if it factors, it'll have to be a 3x and an x. And then, let's see, what are we going to get here? What if we used a 4 here and 1 here? That's going to give us 3 and a 4. That doesn't work. Yeah, that doesn't work. So let's try this instead. Equals 0. We'll go 3x, x. What if we went with 2's in each place? See, a 2, that'll give me a 6 and a 2. I can get a 4 out of that. So I'm going to put a negative over here. That'll give me negative 6 plus 2. So I get critical values here. Here's what we're getting. X equals negative 2/3, right? That's coming from this one. And then we get 2 coming from this one. But look at this. We're on this interval, right? We're on 0 to 5. Now, this number right here is not in there. So we can cross that one out as a critical value. So the only critical value in that interval turns out to be at 2. So let's test. So up here at the top, I'm going to put the derivative. And the derivative I'm going to put in terms of the factored form. So the derivative is 3x plus 2, x minus 2. Let's draw our interval. Now the interval really goes from what? 0 only to 5. And here we are at 2. So let's analyze f prime at 2. So I'm going to pick a test point at 2, right? There's 2. Let me put the 2 in there. So I'm going to pick a test point here from in this interval. How about 1? If I put a 1 in here and then a 1 in here, if I put a 1 in here, I'll get 3 times 1, which is 3, plus 2. That's positive. And then if I put that 1 in here, 1 minus 2 is negative 1. That's negative. So I get a negative here. Positive times negative is negative. So the function is decreasing in this interval. And then let's move over here. If I pick any number in here, like 3, put the 3 in here. 9 plus 2 is 11. That's positive. And if I put the 3 in here, 3 minus 2, that's a 1. That's positive. Positive times positive is positive. So we have a function that is increasing here. So the function is going up, and it's going down, and it's smooth. So it must do this. So we're going to get a relative maximum here. So I know I have a relative max at x equals 2. Now, what I'm trying to get here is not only just the relative maximums, but I want the, all the way back up here, right, the absolute max. So I'm going to create a table here. Here's, let's see if I can create the table. X, f of x. So I'm going to start here with 0, then I'll put in our 2, then I'll put in the 5. I need to know what happens right at the endpoints of this interval. What happens at the endpoints? What kind of values do we get there? So at 0, if we put 0 back into the original function, I put zeros in here, I end up with a 1. All right, so I get a 1 here. Now if I put 2 in here, so I'll put 2 in here. Now this is your calculator going on here. Put a 2 in here. This is not too bad. Put a 2 in here. You get 2 cubed is 8. Minus 2 squared is 4, minus 2, 8 minus 8. And then, where am I? I'm at negative 8 plus 1, so I'm going to get a negative 7 here. And then put in the 5. So I'm going to put in 5 here. Now, this is a calculator problem. I'm going to get 5 cubed minus, all this. All right, so on my calculator, when I did that, I got 56. So here's what I'm going to conclude. I'm going to conclude we have a relative maximum at 2 and negative 7. Then we're going to have an absolute maximum. Now the biggest that the y's ever get, that's down here, right? That's the 56. That's the biggest y that there is. This is the absolute max here. So that's going to occur here at, what, 5 and 56. And the one up here, we don't have to worry about that. That's not a relative maximum or it's not an absolute maximum. So I think we've done what we've been asked to do.